milliliter equals how many microliters? Milliliters is 10 to the negative third. These should be superscripts, I'm sorry, I made a typo. Microliters should be 10 to the negative 6. So I have to move 3 spaces, right? I have to move my decimal 3 spaces. And I'm going from larger to smaller, so I have to go to the right. So if I take my 0.1, move it 3 spaces, 1 milliliter equals 100 microliters. So the maximum volume in our small pipette is 100 microliters. So that equals 0.1 milliliter. So officially we put 0.1 milliliter. Let's figure out how many milliliters is 10 microliters. If 100 microliters is 0.1 of a milliliter, how many is 10? What's 1/10 of that? Right? Because I'm going to get rid of a 0. I have to move 1 space. So I move 1 space that way. So 0.01, 1/10 of a milliliter equals 10 microliters. So that's what your small pipette holds. From 1/10 of a milliliter, from 100th of a milliliter to 1/10 of a milliliter. And that's why when you set your dial, sometimes it's a little funky because your dial only has 3 digits on it. So you have to make adjustments for that. On our larger pipette, sometimes on your exam you'll get a question. You have to transfer this much volume. Which pipette are you going to use, the big one or the small one? Okay? Your larger micro pipette goes from 100 microliters, we already know what that is, right? To 1,000 microliters. So if 1,000 microliters equals 1/10 of a milliliter,
1 milliliter.
1 milliliter.
thank you. Let me put the 0.0 in there to be official. Because we multiplied by 10, so we have to add a decimal point. We're going to move to the right because we're going larger. Here's an easier way to think of it. Here's 1 liter. 1 liter is 1,000 milliliters. 1,000 milliliters. If I had a 10 milliliter beaker, how many times would I have to fill the 10 milliliter beaker to fill the 1,000 milliliter?
10 times.
10 times, right. What if I wanted microliters? How many microliters do I need to make a liter? $100,000. I need 6 zeros. 1, 0, 0, 0, 0, 0, 0. I need 6 zeros because it's 10 to the 6th, or 10 to the negative 6th. Okay, so practice that. Scientific notation. If you look in your textbook, some mathematical considerations in microbiology. First one is scientific notation. Then they teach you about logarithms. Why do we care about logarithms?
That's how bacteria grow.
Because that's how bacteria grow, right? Logarithmically or exponentially. Then they teach you, you can calculate the generation time of your bacteria.
You're not going to do that, right?
No, but you might do this. If every time my bacteria double, every generation they double. So the first generation, let's say theoretically, is 1 cell. It doubles out 2 cells. Next generation, 2 cells double to become 4 cells. 4 cells double to become 8 cells. 8 double to become 16, 32, 64. What is the formula for generation time? What if it's 100 generations? How many, if I start with 1 bacterial cell and I let it divide through 100 generations, how many bacterial cells am I going to have now? They double every generation.
To left.
Generation is n. If I let them go through 100 generations, I have to calculate 2 times 2, 100 times. 2 times 2 times 100. 2 to the 100. Let's do something easier. What if I only let them go through 3 generations? Then n equals 3. That's 2 times 2 times 2 is what?
16.
Good. So, that's generation. That's the number of cells per generation. Put your number of generations up here. They double in each generation, so it's simply 2 to the n.
It's 8, sorry.
8, thank you.
4 is 16.
Okay, yeah, because 2 times 2 times 2 times 2. Okay, so you understand generation. All right, let's just quickly do scientific notation. I'll just blow it up here.
I'm not gonna lie.
Scientific notation means scientists just have their own funky way of doing things. And one of their funky ways of doing things is they don't like to have a lot of zeros to deal with.